Last class, what we discussed? Last class we discussed about so master slave configuration. So if we use edge trigger, so then latch if we are giving triggering, then also it will become say flip flop. It looks like it work like a flip flop. These things we discussed in the last class. So if I want to make a SR flip flop master slave configuration, my master should be SR latch, slave should be D latch. Okay. If I want to make JK flip flop, JK latch. Master should be JK latch, slave should be D latch. Always slave should be D latch. So those conditions, those rules and regulations go with those things. So now today we'll discuss very main important topic which is related to STA. Means the interconnection between this digital to STA. How the interconnection, what are the timing arcs are present in the flip flop. These all things today we're going to discuss. Clear? Yeah, I will explain after this. We need to be explain min emissions, more emissions. After min emissions, more emissions. Okay, so with overlap, without overlap, how that circuit implementation. After completion of that, I will explain the binary numbers. Okay, means yeah, we go BCD, these all things. Very simple. We will take 1 or 2 classes. That's it. Clear? So we'll start now. To expect to this one flip flop. So a flip flop, how we are represented up to now? We represented. See now whatever we discuss in the related to real world of VLSI. Whatever the flip flop can be represented in different ways. Different ways we can represent that flip flop. But in the VLSI, in the digital circuits, how the flip flop will be? Actually, how the flip flop will be? That will going to be represented. Clear? So how it will be means the transmission gate will be there. Then inverter followed by inverter. Then one more inverter. Then one more transmission gate. This also transmission gate. Here also we have transmission gate. This configuration is master configuration. This configuration is a master. This configuration is a slave. So here both are D. That's why same thing will be evolving same thing. Okay. Slave. Clear? So this is transmission T1 gate. Okay. T2 transmission T2 transmission gate T3 T4. And this is the D, that is a Q. So Q bar will be here. This one is Q bar. If you want to take, most of the cases Q bar will not be taken. Q only they will take and they will convert to the Q. That's it. Clear? So these are the things. Now this one. So this one very important. This one is for suppose negative trigger. This one is quite opposite. This one is whatever T3 will be turned on, the same way this one also. This one is quite opposite. The bubbling, whatever I did, T1 and T3 quite opposite. T2 and T4 quite opposite I did. T3 and T2 will be same. T4 and T1 will be same. Okay. So now how the operation will be means, if a clock pulses, if you consider how the clock pulses like this, right? Like this. So now for suppose consider master is a negative trigger, slave is a negative level trigger, slave is a positive level trigger. Master is here it will turn on, slave here it is turn on. So then this flip flop will called positive edge trigger. 0 to 1 it is going positive edge trigger. Okay, clear? So now when master is turned on, master turn on, how I can say transmission gate T1 What is the transmission gate first? What is the transmission gate? We discussed, right? NMOS and PMOS both be connected. We make the transmission gate. Okay. So this one is NMOS. You observe, yes or no? This one is PMOS. So both are connected. Why we both are be connected? One NMOS and PMOS. Why we connected? Why we need to use transmission gate in the flip-flop? Unnecessary extra gates, right? Extra delay, extra processing. Why we need to do that? The main reason behind it, okay? So D can be 0 or D can be 1. If I will use here only this one, what PMOS, it can produce strong 0 but weak 1. Only NMOS, if it can produce strong 1, strong 0, weak 1. In PMOS, strong 1, weak 0. It will produce like this. If I will connect both, what happens? If I will connect both, so then we can produce strong 0 as well as strong 1 now. That's the reason we will use the transmission gates. Okay, signal should not be dropped. Getting? Signal should not be dropped. So this is the thing. So now when master will be turned on, I can say when T1, okay. So master when it will turn on means T1 under T4 on time. It will be on. Okay. When these are on, okay, T2 under T3 will be off. Slave T2 under T3 on, T1 under T4 off. Getting? These are very important. So now see, I am giving data 0. I given data 0. So when negative levels are came, this T1 is turned on. Okay, T4 also turned on. Previously, whatever data is there, that data it is passing to output continuously. When this T1 is turned on, whatever D0 is there, this 0 will pass to here. So then inverter 1 is there. This inverter 1, okay. This is the inverter 1. This is inverter 2. This is inverter 3. This is inverter 4. This inverter 1, this 0 will pass through this inverter 1, it will generate 1. This 1 will goes to here. This 1 will comes to here. So this one will pass from here to here. Clear? So when after inverter 2 it is reaching, so then I can say that this data is stored. Whatever D0 data stored. Same case D1 also. When D1 you are giving inverter 1, inverter 2, transmission get 1 to inverter 1, inverter 2. So then it will be stored. So after that, this negative pulse will be completed. This positive pulse will comes. When positive level will comes, this one will be turned on. This one will be turned off. Okay, whatever this 0 will be there, this will be goes to output side. This one also turn on. This one is turned off, right? So it will go to output side and it will go to here and latch. Here also it will latch. Will be happen. Means holding state. Getting? So it will go to the output side. Means so one negative level is required, one positive level is required. Completely data passes from D to Q. One negative level is required, one positive level is required. Complete data passes from D to Q. Now my question is, okay, how I can guarantee my data is stored? Who will says, okay? So how much time I need to take? Okay, how much time I need to take? My data is stored. For suppose consider you are traveling from here to Hyderabad. You started here at 6 p.m. night. So how I can guarantee that? How I can say that okay, this X person is reaches to Hyderabad? How I can guarantee that? The time is taken, right? The time taken to travel from the Bangalore to Hyderabad, some time will be there. Based on the travels, it will change. Based on the stop points, it will change. So no, based on the traffic also it will change. Many parameters will be there to decide one time between the two locations. Yes or no? The same way, how I can say that okay, my data 0 or data 1 is stored properly in the flip-flop. How I can guarantee that? We need to have some parameters, right? Based on those parameters only, I can say that the my data is properly stored or captured. So those are very important. What are those? We'll see now. So now this data is up to inverter 1, inverter 2 this passes, then I can say that okay, that data is stored. Either whether it is 0 or whether it is 1. Means simply what I am saying means T1 transmission gate T1 on time plus inverter 1 on time plus inverter 2 on time. So this time, if this all reaches to here, so data reaches to here, that may be 0 or 1. So then I can say that data is stored. Okay, that data is stored. Still we have a problem. Okay, data can be overwritten problem. Still we have. Okay, so up to that. Okay, means it is T1 on time, inverter 1 on time, inverter 2 on time. Data should be maintained same. If data is 0 at the D pin, they need to maintain up to here same data. If data is 1, they need to maintain up to here same data. I will give examples. Okay, real examples I will give. You will understand very easy this one. So no doubt this will take one class, but very easily you will understand. Okay, so this is D0 or D1, same data need to be maintained up to reach to this inverter 2. So after reaching inverter 2, then slave will be turned off, means T2 will be turned off and T3 will be turned off, T1 and T4 will be turned off. So then this data will be go to the output Q. This data will go to the output Q. Data is not directly going to Q from D to Q. Getting? Data is coming from D to inverter 2. After that T2 is turned on, from the T to 2 it is going to Q. Clear? Data is not going directly, one node point is D to Q. Now come to the point. Now for suppose consider each and every gate in the digital circuit will have some turn on time, turn off time, right? If I am giving clock signal here, okay, so positive clock signal here, so this one is going to be turn off. Yes or no? T1 going to turn off, T2 will be turn on. Because this one is clock only, these are clock, okay. This one is CLK, this one is CLK bar, this one is CLK, this one is CLK. Sorry, this one is CLK bar, this one is CLK. Okay? This one is CLK, this one bar CLK. CLK bar CLK. Getting clock pulses. Based on that, it will be turn on, turn off will be there. Clear? So now this one is okay, turn off. T1 is turn off. Now T2 is turn on. Based on the clock pulses, T2 is turn on. But when I clock it switches from 0 to 1, immediately T1 will go to off. Immediately will go to off. It will have some time to be turned off. So it is slowly turn off. When it is slowly turn off, okay, the movies, okay, when gate is slowly closing, hero will enter, right? The same way what happened, okay, data is changed here. Previously data is reaches to here 0. But when it is closing the door, okay, when it is transmission gate is turned off, then suddenly hero entries came, new data on. Now, when this one is turned off, this one here we have 0. This one is 1. This inverter one, which one it will take? Which one it will take? 0 it will take or 1 it will take? Don't know, right? Metastability state. No doubt. Metastability state. Metastability state. If new data overwritten, new data, okay, come before, okay, comes when new data will come when T1 is going to off state, then there is a chance of inverter 1 can get two signals 0 and 1. Then there is a chance of inverter 1 get two signals 0 and 1. So this inverter may not be taken, okay, neither 0 normal case, that is neither 0 normal case only metastability state. Clear? Simple. See, don't focus on whatever I am saying. First listen. T1 is off. When it is going to off, new data is entering. New data is entering. It may cause to be 2, 0 and 1 to this inverter 1. When it is cast to 0, 1 to this inverter 1, so neither 0 nor 1, which one it will take, it don't know. Combined together it can take, or it can take 1, or it can take 0. We can't say metastable. The state is not stable, okay? Metastable. So it is not means neither 0 nor 1 case. Anything can happen. So that is only metastable we can say. Clear? Clear? So this is the thing. Now, how I need to avoid? How I need to avoid? Before this, I will explain one real example. Real example we'll see. For suppose consider. So you are in PG. You are in PG. Okay. You need to travel from here to some. For suppose consider HSR layout or some place. So Mahadevpura, otherwise Electron City, some places you need to be travel. From your PG, first where you will go? You will go to bus stop, right? Bus stop. From that bus stop, you will go to destination. Whatever, based on your destination, you will go. Now, for suppose consider at the bus stop, bus will come at 10 a.m. Bus will come at 10 a.m. But from your PG to bus stop, the time taken is 30 minutes. 30 minutes. Without traffic. Without traffic. With the traffic, 40 minutes. 40 minutes. Means how much, at which time you need to start at the PG? At which time you need to start at the PG? 9:20. If perfectly you want to reach 9:20. Yes or no? 9:20. So if you know, so okay, traffic will not be there, you need to start at 9:30 also, you can reach. Yes or no? So now you came to bus stop. Okay. So you are very thirsty. You went to one shop and you are taking the water. At that time, bus is left from the bus stop. You will reach the destination. No, right? You came to bus stop, but you need to catch that bus. Then only you can reach to the destination. Until unless that destination, you need to be staying in that bus. Then only you can reach to the destination. Now see. Now here, assume bus is a clock. Person is a data. That means 0 or 1. Person means girl or boy will be the right data. 0 or 1, anything. Now, data started at D. This is T2 is a bus stop. T2 is a bus stop where clock also will come, data also will come. But clock directly can come, but the data need to be traveled T1, inverter 2. This much delay it have. These 3 stages it need to come and then it will be ready to T2. So then clock will come and push to next state. Push to Q. Means from here it will have stop inverter 1, inverter 3 here, transmission 3, inverter 3, then it will reach to destination Q. Getting? So now it need to reach to here, right? Means the transmission T1, inverter 1 and inverter 2. This time only called T setup time. Means data need to be start before the person need to be start before the bus come to the bus stop, because this person have some delay before itself only have delay. Getting? So he need to be start the same way. So data also need to be start before the clock edge. Before this clock edge, data need to be start. See, he started at the PC. He have a mindset that he need to go to some destination. When started in the middle, he thought that okay, no, I will go to my destination. He will reach to his destination. No, right? When he started in the PC, okay, his mindset, whatever his mindset is there, until unless he reach to that destination, he should maintain the same mindset, then only he can reach the destination, right? The same way, when the started data is started here at the D, so the data reaches to bus stop, until unless the data should be same. After that bus catches, okay, until unless reaches to the queue, the data should be same. Then only it will be data is stored and data is transferred to the output queue. Clear? Now see what happened. The setup time. Keep a note down the definition of the setup time. Setup time, very important. Two times you should know. One is setup time. The time taken to be, sorry, the minimum time, data should be stable. The minimum time, data should be stable. The minimum time, data should be stable before active edge of the clock. Before active edge of the clock. The minimum time, data should be stable before active edge of the clock. Means what I am saying, minimum time. What is that minimum time? That minimum time only T1 transmission get on time, inverter 1 on time, inverter 2 on time. Not do that. Setup time, T setup time equal to T1 transmission get on time. Okay. Inverter 1 get on time, inverter 2 on time. Inverter 1 get on time, inverter 2 on time. This through this, okay, the data will pass. So that is the setup time. That is the setup time. Setup time means, okay, data reaches to one station which will carry to the output queue. Okay, data, the clock will be taken and it will carry. So now the question is, I reaches, okay, bus stop. If I catch the bus, then I will go. Even I will catch also, I need to be stay in that bus. Yes or no? The same way, I reaches to here when this one is coming. Okay, when this one is coming. So when this one is coming, it will turn on, right? When it is turned on, okay, this data is going like this. This one is turned off case, data is one more data is coming. Means one more data when it will comes, D is changed, then only it will comes. D means mindset change. So no. So mindset change after bus, he getting to the bus mindset change, immediately next stop is dropped. He will reach to the destination. No. So the same way here data is changing. New data is coming means D changed. So then only, so we get 0, 1 case here. The data should not be changed. Up to which time it should not be changed? Up to this T1 turn off time. T1 off time. Okay, before the clock edge, data should be stable. So that is the setup time. Okay, after the clock edge, okay, up to this T1 off time. So the data should not be changed. Data should be same. So that is hold time. T hold time. T hold time equal to T1 off time. T1 off time. Okay, note down the hold time definition. Note down the hold time definition. The minimum time, data should be stable. The minimum time, data should be stable after active edge of the clock. After active edge of the clock. After active edge of the clock. This is the hold time. This is the hold time. Clear? Now, so when data is properly captured and transferred to the output queue, so when I can guarantee that? When I can guarantee that one person is reaches to Hyderabad or some destination, when I can guarantee that? First, he need to be reached on time to the bus stop. After that, he need to be catch that bus. He need to stay in that bus. Then he can reach to the destination. Okay. The same thing here also. When the data is properly captured, I can guarantee that. So when the data should be reached on time to this, Okay, after inverter 2, okay, from that inverter 2, it need to be, should not change the data, same data should be maintained until unless it reach the output U. Okay, so that is the T1 on time plus T1 of T setup time plus T hold time. If you admit these 2 times, then I can say that my data is saved, stored, and transferred to the output queue. Clear? Clear? See, when this one is turned on, okay, this one also turn on. What it will do? This one is turned off, means this one separate, this one is separate, 2 separate sections. So what it will do? Previously, whatever data is there, this data it will be continuously, it will be gives to the output. Getting? When new data will come, so okay, when new data will come, it will goes like this and it will come and it will ready to latch next state. Getting? Next condition, next pulse will come, it will latch the some new data. Like that it is. Getting? It's very, very important. Flip-flop, okay, flip-flop circuit is flip-flop, how internal data distribution will happen is very important. And one more thing, in entire your career as a PD engineer, so you will be okay work very hard to make this setup time and hold time. This is the complete life. Your complete life will be setup time and hold time. It's look very simple. Okay, setup time only na, hold time only na. So we can meet now. No, it's different methods will be there, different ways to be calculated. Now here I am saying T1 on time, T1 on time, T1 on time. It is general equation I am saying. But actually when you are going, okay, so which one is more delay? T1 is more delay, on time is more delay, off time is more delay. So based on that, okay, they will be take worst case. Worst case they will take. How I told here, okay. So see, T1 on time is okay 30 minutes delay with the traffic. Okay. T1 off time is 40 minutes delay with the traffic. Which one taking is better? Which one considering is better? 40 minutes if you consider, 9:20 only will start and you will reach on time to bus stop. If traffic also there, you can manage. Okay, if traffic is 9:30, traffic is full is there, so then you will reach at 10:10. Then you may miss the bus. So no. That's what only I am saying. The definition which I told here may not be maintain the same. At starting understanding, I given this. Later it will change when you calculating the timings, when you calculating the STA, complete STA. So when I will start, I will tell you how it will change. Okay, starting timing analysis. In the starting timing analysis, these 2 technologies are very important. Setup time and hold time. I will guarantee that 100%. Go and ask any batch who completed the course. Go and ask setup time and hold time. Just they will give the definition, but they don't know. Okay, T1 on time, inverter 1 on time, inverter 2 on time. I will guarantee that. Because this is, if you are not understand this, people will consider like okay, digital and STA will be different topics. No, the extension of digital only STA, in my point of view. So why the extension of digital only STA I will say means, so in the digital what you will learn is okay how the logic is going from one input to other. What is the relation between output to input? Okay, which are the logic gates we are using? This will be knows in the digital. In the STA, what it knows means how much time is taken to generate this Q from D. What is the delay of this inverter 1? What is the delay of this inverter 2? What is the delay of this transmission gate 2? Okay, how much time it is taking for propagating delay for propagation of the data from the input to output? What is the delay taking from the, okay, what is the time setup time? T1 on inverter 1, inverter 2 setup time, what is the setup time? What is the hold time? These all things you will be knows in STA. Which are the parts of related to digital? Get here? Digital extension only STA. So people will think that okay, this is different, that is different. No, this is. See, instead of these inverters, you can replace with an AND like this. Getting this, right? You can replace this inverter with this NAND. Means in the, if you go in the Google, if you search, right? So you can get this circuit as well as this circuit also. Both are same. Don't think that okay, SAR teach only this circuit. SAR skip that circuit. Both are same. Clear? So now we'll see how the timing are. how the timing is. This is the flap, right? This is the flap. Let's consider D is there, CP pin is there, then Q is there. D is there, CP pin is there, Q is there. Now, so have data is directly passing to the Q? No. Data is coming from D1 to inverter transmission gate 1, inverter 1, inverter 2. After reaching here, when clock comes, clock will push from T2 to inverter 1, T3, inverter 3, then Q. Means there is no timing arc between D to Q directly. So how the timing arc will be? D2 clock CP pin, from CP pin to Q. CP pin to Q. So what CP pin to Q will be TP, propagation delay. Propagation delay. What is this propagation delay? Propagation delay, if I want to say in the terminology, T2 on time, T2 on time. So inverter 1 on time, T3 on time, inverter 3 on time. So then that is the propagation delay TP. Okay, propagation delay TP. So now this, okay, D2 CP is there, right? So here two things will become. Okay, D2 CP, T setup, T hold. Two times will become. T setup time, T hold time, two times will come. So then CP to Q. This is the general things. So we already discussed, okay, reset pin will be there, set pin will be there, right? So if reset also there, reset related also two timing arcs will be there. Okay. So reset are clear. So these two timing arcs will be there. So these also same. CP, so reset to CP, then CP to Q. This will be same. CP to Q it will be same, but reset to CP will be there, right? So these will be two types. Okay, one is recovery, one is removal. Recovery and removal, two timings will be there. So recovery, removal, same as like the setup and hold times. Little bit definition will be changed. That we'll discuss when we start the STA. So when we start the STA, so these all timing arc informations will be there in the .lib file. .lib file in the J Bhaskar one book will be there. J Bhaskar book, very high level #1 book. If I want to suggest for STA, that is the J Bhaskar book. So in that J Bhaskar book, second chapter, this one will be there. This one will be there. That J Bhaskar is very important. So in that these timing arcs will be there. If you understand these timing arcs, so then you can understand the STA very easy. Simple. Nothing is there. Is there any difficulty? Is there any difficulty? Is there simple? You need to know first T1 and T4 on time. T3 and T1, T4 when on. T3, T2, T3 will be off. T1, T4 make okay master to be turned on. Okay. T2, T3 will be made to be slave to be turned on. Getting master to be turned on and slave to be turned on. So when T2, T3 turn on, T1 and T4 will be off. So these things, if you know, okay, how the data is transferring from one state to other state. What is the setup time? Next, after this, what we need to know? We need to know setup time. We need to know hold time. If you know the setup time and hold time, to meet the setup time, if you meet the setup time, if you meet the hold time, so then flap properly operated and it will store the data properly and send the data output queue properly. Yes or no? So those things only. So whatever the data setup time, okay, how the timing is going and how it is reaching to queue, so that if I will represent it in the arc format, so those only these timing arcs. Okay, those only these timing arcs. Any questions, any doubts? Any questions, any doubts here? Very simple topic. People will see when one topic to other topic gap will come means, okay. So if you are not understand the topic properly, then only gap will comes. If you visualize everything properly, so then there is no gap. So now this one is clear. So now when STA will come, okay, what we will discuss, we will make, okay. I will draw this one flop. Some combo logic means buffers and matters, anything will be there. This combo logic they will make as a cloud. They will represent in the cloud. So one more flop is there, one more combo logic is there, one more flop is there. Clear, like this it is there. So this is the clock. This is the clock. This is the combo logic. It is going to output port. Okay. This is the combo logic. It is going to input port. This is flop 1, flop 2, flop 3. This is the D. This is Q. This is D. This is Q. This is D. This is Q. Getting? Getting? So now I given the data here is 0. It will combo. Okay. It will go through this combo. It is produced some 0 data. It is produced going through this combo. It is produced 1. This data D1 is reaches here. Inside this one need to be go to the store, right? Store the data, right? When inside the data storing process only what we discuss here. What we discuss here. That inside data it will stores. It will stores as well as it will transfer to the queue. After it will go to the queue, this combo performs and it will go to the D2. Getting? D2 will be stores. When D2 is storing, again it will take new data to here. Getting? When until unless this D2 stores, this queue completely give the previous output. Previous, for suppose first I given 0, next I given 1. First it will store 0. So this 0 it is giving. Which one is giving 0? This latch is continuously giving 0. When it is giving 0, this one try to store 1. Let's take a 1. Getting? When this is storing 1, it is continuously giving 0 previous data until unless this one will be turned on, it will push to queue. Getting? Very important I am saying. The timings are whatever discussed, okay? So they will ask, okay, between this flop 1 to flop 2. Flop 1 to flop 2 timing, okay? So is the setup time is met or not? Hold time is met or not? They will ask. So you need to by seeing the delays, everything you need to say. Where is the setup time? People will be setup time means okay, somewhere it will be, somewhere it will not be there. Setup time when you will check. And here to here only, right? Setup time. Sir, no. Hold time also here to here only, right? Hold time means flop 1 to flop 1, Q pin, flop 1, CP pin, from CP pin to next flop, okay? Next flop, CP pin, you are checking, that checking only setup time and hold time. If hold time means it is faster, data path is faster. Setup time means data path is slower. Simple. Terminology is simple. Understanding, the way you understanding, the way, see, same circuit people will be looks in different ways. If people who don't know inside of the circuit, they will think, okay, D is connected to combo logic, Q is connected to some combo logic. Okay, setup time will be there. What is the setup time? They don't know. Inside setup time will be there. They don't know that first. If they don't know inside setup time will be there, how they can visualize and how they can calculate it, and how they can able to solve the problem when setup time is fails, when hold time is fails. Getting? That visualization is very important. This internal topic is very important. I will suggest you that after completion of this class, go record section. I think tomorrow they will upload. I think go with that record section 2 times, 3 times, 4 times. How much time? Okay, you want to go until unless these topics are discussed. Why? Because this is a basement of your complete STA. Basement of your complete STA. This topic, if you understand, I will give, okay, written note that, okay, you will understand complete STA on this topic every time, okay? So you will say, okay, very easy, next topics are very easy because it is like a chain. This one is, you will understand, next topic is very easy to do. Clear? Any questions, any doubts here? This how the setup time, hold time we'll discuss in the STA. So let's make it simple here. So we'll discuss in the STA, okay? So now any questions, any doubts regarding setup time and hold time? What is the setup time definition? The minimum time data should be stable before activate of the clock. The minimum time data should be stable before activate of the clock. What is the real equation if someone asks? T1 means people will don't know, right? T1 means transmission gate 1 on time, inverter 1 on time, inverter 2 on time is called the setup time. Okay, that whatever minimum time you are saying, right? That is called the setup time. Clear? So then what is the whole time? Definition. The minimum time data should be stable after activate of the clock. After activate of the clock. So one flow properly data is okay stored and transferred. When I can say that when my flop is meet setup time as well as hold time. These are the interview bits, whatever MCQ bits, they will ask these things only. What is the setup time equation? They will ask. Okay. What are the gates of on time or off time? Okay. Setup time. What is the hold time? Okay. When I can say okay, my timing is met. Yes or no? What are the timing hours? Okay. So what are the timing hours you can observe from D to CP, CP to Q? Yeah, so these things only. Nothing else will be there. Means that the internal concept that guy is understand or not, they want to check. If internal concept, if you understand, then this calculation is okay, like easily drinking water. That internal concept only very clear. So go with these things, okay? Go with the record section. Come up with the questions and doubts. In the next class, we'll start, okay? Relay, emissions with overlap, without overlap, sequential sequence detection will be there, right? 101 sequence detection, 111 sequence detection with overlap, without overlap. After the sequence detection, okay, in the Melee and Murray. So how the circuit implementation? These all things we'll discuss in the coming classes. Upcoming classes, I think 2-3 classes. This one will take. After that, we'll start the number systems. Number system 1 or 2, 3 classes. Mostly one more 6 classes. Digital will complete. Clear? Digital will complete. So next I will start RTL. Then I will start, okay, after RTL I will start DFT. These two completed, then I will start Linux. Why? Because I think next month I will go to the hometown. At the end of the next month. When I go to the hometown, when I am taking the online class, if I will take the Linux, the understanding will be easy. Because Linux are all our commands. I will execute and I will show you that this command will be to do this one and the output will comes like this. So no need to be sit and explain. But this RTL, this DFT, these all things need to be in person, need to be explained and you need to be understand. Clear? So that's why. So go with these things, okay? So yeah, I have that plan. I will explain properly the plan, okay? So we'll go in the flow. Clear? Yeah, if you want to plan, you can plan, okay, from I think May 26. 26 I will go. Means I will take online classes, don't worry. I will take online classes May 26 to June 5 6 like that. Then offline again, offline classes. But I will make sure you will understand everything. Like that only I will plan. Clear? Yeah, I'm stopping here. Any questions, any doubts, you can ask me the questions or not. Otherwise, I'm sure. Okay. Yeah, thank you guys.